He said he might be working, but he might come. I never know.
All right, we're live.
Right.
So this is Google changed the interface on this stuff once again. But so hopefully this will be recorded and will be available to people via Hangout on Air or YouTube or whatever they're calling it these days.
And then we'll go back just a little bit.
So I'd like to introduce our speaker, Jae Kwon from Tendermint and Cosmos.
Hello, I'm Jay. Nice to be here. Hello. I should talk to the real room. Thanks for coming. It's an honor to be here. And I'm going to talk about Tendermint and Cosmos. Should I just get started?
Sure.
Okay. So, all right. So I'm going to start by talking about what Tendermint is about. Tendermint is this open source blockchain engine. Unfortunately, we can't see anything because it's too bright.
Can you turn off the lights?
No, I don't think we should. I think it would be better if we left the lights on. And that sort of doesn't work.
What's the problem?
It's
Just
just
can't
it's not
see the-
recording. I mean, you can't
Oh,
see
oh,
the
oh.
screen. I think it's okay. We can just go on.
How's yours doing?
Mine's fine.
Casey.
Okay, great.
Mine's recording.
So Bitcoin is amazing because it's this thing, this shared ledger that we can all share, that we can all agree on, and it works despite it being open. So like normally, if you just open a database to the public, then people will spam it. So you can't let everyone be able to write to like a typical SQL database. But with Bitcoin, like everyone can participate, but despite the fact that it's open and vulnerable, it still continues to function because it's Byzantine fault-tolerant. And what that means is that it can tolerate actors in the system that are trying to attack it. So we used to have the PC, and if the computer went down, then your service went down. So that's what used to happen until like Google and Facebook came out and started using fault-tolerant algorithms and replicated systems. So what that means is when a machine goes down, it's fine because you've got backup replicas that are going to take over the machine that went down. Doesn't matter that one goes down because they're all kind of doing the same thing. So it's fault-tolerant. It can tolerate crashes. But that's not the same thing as the kind of fault tolerance that Bitcoin provides, because the kind of faults that Bitcoin provides is one where like a machine can get hacked and try to disrupt the system from within. So for that, you need a new class, a different class of fault-tolerant algorithm called Byzantine fault-tolerant algorithms. So like Bitcoin was probably the first BFT system to really get used, and I think that's why like we're all excited about it. But it turns out this BFT algo stuff is something that's been in development in research for a long time, like even before the 1980s. So we figured out quite a lot about this stuff. By we, I mean like people in universities. But none of that was really used because people didn't know what the use cases would be until Bitcoin came out. So, like here's sort of the history of these algorithms. It started in 1985 was when there was this first theoretical breakthrough about what's impossible about consensus. And the FLP result says that it's impossible to come to consensus in a completely asynchronous environment with even one computer that can go down. So people are thinking, oh, like consensus is difficult. But then a few years later, people solved it. They're like, oh, right. If you just make a slight assumption about the availability of clocks, then you can solve the consensus problem. And this is, all right, yeah. And then 1999, like 11 years after that breakthrough, there was a paper published at MIT describing a file system that is Byzantine fault-tolerant. So, rich history of these algorithms. And then, totally out of the blue, Bitcoin came out in 2008 with a completely different solution to the problem of BFT consensus. The difference between what Satoshi came up with and what was already existing is that Satoshi created an algorithm that requires mining to come to consensus, but all the other stuff was developed with the idea of actors, validators, who are signing signatures. So the consensus algorithms developed prior to Satoshi was based on public private key pairs and signing. So yeah, so nobody was talking about this 2 years ago. And then I looked at some papers and figured out that this was possible, so I got excited about it, and that's why I started working on Tendermint. And what Tendermint is it's an open source engine that solves this BFT stuff so that you can create your own blockchain and have Tendermint handle all the peer-to-peer networking and consensus for you. So Tendermint is like this open source blockchain. You can use it to create your own consortium or private or public blockchain, proof-of-stake chain. But you have to provide it like the logic. So Tendermint by itself doesn't know what those transactions mean. All it knows is how to come to consensus about what the order of transactions should be. But it doesn't know what the transactions mean, doesn't know anything about the application state. So it's up to the blockchain developer to provide that logic and pair it with Tendermint to create a blockchain. So that's Tendermint. We've been working on it for like 2.5 years. We're going to have the first production version like in January, so we're really excited. Just today, we made a small announcement about integrating Tendermint into Go Ethereum. So there's this. So now, a lot of people in fintech have been using Ethereum, like stock Go Ethereum, to create their own little network, test network, and to test out their fintech idea, proof of concept. And they were having a hard time with the proof of work component of their small little sidechain or consortium chain because, like, it's obviously not secure if you have your own chain where there's not enough economic incentive for miners to come in and mine it. But also, like, blocks come in at random times. It doesn't come at regular intervals. These people want something faster, right? Especially for something like Ethereum. So it's really nice for like that. You can now pick. We've already done this where we've taken Tendermint, plugged it into Go Ethereum, which is an existing Ethereum stack. Now you can create your own, launch your own consortium chain. I can talk more about it later. But okay. Yeah, does anyone have any questions about like proof of work? And I'll go a little bit into proof of stake, what proof of stake looks like on a BFT engine like Tendermint. So the model is different. And to illustrate it, I like to talk about an example, a sample question. And that is, like, how many confirmations would you wait for in Bitcoin if you wanted to confirm a very large transaction? So in the Satoshi white paper, like, they say you're supposed to wait like an hour or 6 confirmations because probabilistically, an attacker with less than 49% of the mining power won't be able to overcome, and create a double spend attack. But like, that's assuming that these miners are not incentivized to perform the attack. But as we've learned with the Ethereum and Ethereum Classic, like hard fork. The miners are there to make an ROI. They'll pretty much mine on whatever chain that they're paid to do. They don't really have a whole lot at stake when it comes to, launching an attack, because if they hold any coins in the chain that they're attacking, then yeah, they have something to lose. But like their hardware, their mining infrastructure, all of their hardware and the location that they're at and their access to cheap electricity, all that's not going to change after an attack. They can use that same equipment to mine on something else. So there's no reason they wouldn't try to attack a chain if they were paid to. So the white paper answer is you wait 6 confirmations. What does that turn out to be? So it's about today's, given not today, but a month ago, Bitcoin prices, yeah, $600 a Bitcoin. That's $7,500 a block. That's how much the miners are being compensated for their mining work, which means that's how much it takes roughly to bribe the miner to mine on something else. So if you have a $100 million transaction, you probably want to wait more than 10 blocks, just if you really want to be safe. If you were paranoid, right? Obviously this is not a plausible attack scenario without a plausible attack. But anyways, so with that in mind, the difference between proof of work and proof of stake is that in proof of work, even before you launch an attack, you have to start paying for it with electricity. So the cost of the attack comes before the attack has manifested. In proof of stake, it's the other way around. The BFT algorithm ensures that the blockchain doesn't fail unless more than 1/3 try to attack it. So as long as the number of attackers, or the proportion of attackers on a BFT chain is less than 1/3, the chain will continue to function fine. Right? So it's fault-tolerant. Another nice property of the proper BFT algorithm is that once an attack has happened, you can figure out who they are. I'm not talking about figuring out who the people behind it are, but the pseudonymous signing entities. You can figure out which keys are responsible for that attack. And you can do that by after the attack has completed, you can ask all the validators to share all the signatures that they've seen that caused them to sign whatever they signed, and you can just review it and be like, okay, well, there's a deterministic way to figure out who's responsible. Okay, so yeah, so in proof of stake, the cost of the attack comes after the successful attack. But as long as there's a cost, you can prevent the attack from happening in the first place, because either way, there's a cost. Right? With Bitcoin, the cost comes before. With proof of stake, the cost comes after. Yeah, there's more we can get into. But any questions about that so far? Yeah.
A third of what is?
Okay, yeah. So a third of the voting power. So in all the BFT consensus literature that came before Bitcoin and all this stuff, they always assumed a discrete number of machines. So they might assume a network of 10 machines, or for simplicity's sake, let's say 4. Let's say there are 4 machines, and each they're equals, they're peers. So as long as 3 are up and signing, you're good. And if 2 machines go down, for example, then you can't create new blocks. So that's how the papers were written, but you can easily extend that and just say oh, each signer has some rational amount of voting power. You can say each of the 4 machines, or you might have 100 signers. You might say everybody's equal except this signer who has twice the amount of voting power as anyone else. So you just add up all the voting power and you just divide.
So can you assign the distribution of voting power ahead of time? How is it assigned in practice?
I see. Yeah, you have to. Okay. So unlike proof of work mining, where anyone can join, and just the proof isn't the work you've done, right? Anyone can do it. In proof of stake, or BFT proof of stake, like, the only people who can participate in consensus are those that have already, like, on the blockchain, been proven to be part of the validator set. So, but how that happens is completely up to the application in terms of Tendermint. Like, you can have it be a static set. You can have that set be mutable based on logic, governance logic. And in proof of stake system, we're talking about the amount of like tokens that are posted as collateral. That's what we do. People are saying like proof of stake is impossible because of like a nothing at stake problem, but that's not really true. There's ways around it. Yeah. Any questions about that? I can talk about it, but well, the short of it is that, like, one of the problems of proof of stake, early proof of stake algorithms, was that, like, the people who had the ability to commit blocks, like, they could also simultaneously, like, move them and sell them immediately. So, like, they could launch an attack to fool someone and meanwhile be selling the coin on the exchange, on the honest chain, for example, and they can get away with it scot-free. Right? So the solution to that is to require, before somebody can become a validator, a signer, commit a block, you require them to post collateral, and that means that whatever the tokens that gave them that right is frozen, so they can't move it. That way, once they perform the attack, we can figure out who's responsible for it, and we know that their collateral is still frozen there. Definitely punished. But that only works for as long as it takes to get the coins back, right? The unbonding period is what we call it. So it only solves the short range attack problem. In terms of the long range, there's this problem. There's this problem where a validator set, the signing set from like 10 years ago, can construct an alternative fake history that looks legitimate to somebody who doesn't know any better. Right? So there are ways to get around that. The simple way is to require all the nodes, the full nodes and the validators to always be online and to regularly sync. That way they always know what the most recent validator set is. And even for full nodes, you don't have to be online all the time. You just have to come in once in a while within the bonding period so you can sync. For light clients like mobile phone wallets that haven't been online for like a year or more, there's another way to solve this problem with oracles that have collateral that are not validators, so they're not part of consensus on the blockchain, but they nevertheless have something to lose if they lie about what the most recent block is. So that's another way to solve that problem. So Tendermint is an open source BFT engine. It's not just about proof of stake, but we're most interested in Tendermint. It's a great proof of stake chain. What it does is it handles peer-to-peer networking, the consensus, and the broadcasting of transactions. And it has this blockchain structure to it too. But like I said earlier, it doesn't know what those transactions mean. To do that, you have to plug in an application. The easiest way, here's a graphic that kind of illustrates what a Tendermint blockchain network might look like. So the core, this stands for Tendermint. This is a Tendermint process. And your application can be written in any language, like it could be a Java app or a Python app. And the Tendermint process and your application, the state machine, which contains the logic that can make sense of those transactions, it's connected by a network socket protocol, like a Unix socket. So, these two pairs of programs, it could be compiled together if the app is ready to go, because we write a Tendermint ready to that pair is like a blockchain node. And all the Tendermint processes on the internet are talking to each other, sharing information by gossip. And your application doesn't have to talk to the internet at all. It just needs to talk to their respective Tendermint processes. And that's how it works. So what we've done is, I was talking earlier about Ethermint. I don't know if I mentioned the name, but Ethermint is it's basically this project where we took Tendermint and we took Go Ethereum and we mashed them together and we compiled them into one program. So you can launch your own Ethereum chain. And in the future, we're going to do that with a lot more. So like Zcash or crypto, I'm not sure. And other things. We have our own applications that we're developing as well. It's free. The project requirement if you want to use it. So that's Tendermint. Any questions about Tendermint? It's really fast. Like you can have a global like blockchain network with like 100 signers or more, like 1,000 signers. Well, let's just say 100 signers. So 100 validators globally. They can produce blocks every 3 seconds, right? It can go faster, but to be saying, we're just being conservative. And you don't need any confirmations. Like every block is final. So like my phone, my mobile wallet on my phone can submit a transaction, get a confirmation back, meaning like the signatures for the next block, and based on the Merkle proof, instantly know, like have cryptographic evidence that it was committed, and that can happen in a matter of seconds.
So what kind of a chain do you have active right now for Tendermint?
We have a production chain that we're running for a client. It's a voting application. It's tallying votes. So maybe that's something that's interesting.
But it's a private chain.
Yeah, it's like,
you don't have a public test net or anything like that.
Not yet, no. But we're thinking about it. Yeah. So that's one of the things. We'll have a blockchain. I bet a blockchain that does some kind of name resolution, but we'll talk about it.
Okay. Oh, interesting.
Yeah.
I'm interested in naming applications, so I'd
love
to hear about that.
Yeah, I think we got like the certificate of authority system, for example. I guess I'm a naming system.
It kind of is.
Yeah, okay, it is. Yeah, not very secure because I don't know, it's another story. I feel like a Tendermint blockchain could be the ideal system for name resolution and certificate of authorities and all that. Yeah. Any other questions about Tendermint? No.
Where do you start in terms of learning about Tendermint, then in terms of documents?
Oh yeah, just go to Tendermint.com. We just pushed out a new website today. It's got better information. We made it easier for you to just get started.
Give examples of how people arrange their transaction. You said there's flexibility with regard to organize the data in each transaction.
In terms of?
It sounded like they're sort of left it open in terms of how people would structure their transactions.
Yeah.
So are there examples and things like this?
Yeah, we've got some example apps. So if you go to tendermint.com/ecosystem, there's some examples. The one so we haven't actually even finished our like example app, and people have already started building stuff on it. So Basecoin is a thing that we want to continue to build out to be like a fully fledged example application, but it's not complete yet. But you can see it and see like what we're doing there. It does work. And somebody else actually took Basecoin, a company called FXCH, took Basecoin, they modified it heavily, made their own Forex clearing application. We'll be posting that here as well. It's not here yet. And you can take a look at how he tied it into Ethereum. So in that case, it's just an Ethereum transaction.
Okay.
Yeah. And there's some other silly apps as well. Yeah. Okay, so.
One more question. Are you doing some crowdfunding? Have you?
Yeah. And that's not for Tendermint, but I'm just about to.
That's on Cosmos?
Yeah.
Okay.
Yeah, so what we're doing is, so now I'm going to talk about Cosmos. So Cosmos it's a network of blockchains. It's a network of blockchains that are powered by Tendermint. It's a public blockchain, so we're talking about something that's going to exist along with Bitcoin and Ethereum and all that. So for the sake of this talk, I'm going to call blockchain a zone because I think it's a nice name. And because in the public blockchain world, like every blockchain should have its own governance mechanism. It's like they should have their own policies, economic policies. Obviously, like every blockchain has its own inflation schedule. So it's called zones. With Tendermint, it's really easy because the light client SPV protocol is so nice. Like I was talking about how easy it is for your phone to get proof of the most recent block. When you turn a blockchain into a light client of another blockchain, so meaning that data packet that was going to go to your phone to prove the latest block hash and that your transaction went through, that same data packet could actually just be a transaction that gets committed into another blockchain. And then now you're able to talk to each other. These blockchains are virtually speaking to each other, kind of like they would through two computers that talk to each other through TCP or UDP. So we have a specification for this called IBC, inter-blockchain communication, where it's a lot like TCP or UDP between blockchains.
Is it related also to to sidechain, voice sidechains?
Yeah.
Main chain?
Yeah, so it's very similar in concept to what Blockstream is doing with sidechains. Yeah, except instead of having Bitcoin at the center, where it's proof of work, so like in sidechains, like every node would have to, the sidechain validators, signers have to track the proof of work. And that's complicated because it's a formful system. And it's slow because you have to wait. You want to wait like 6 hours to convert something. Because if you're wrong and the fork is more than 6 blocks worth, you're going to lose something. So instead, in Cosmos, you're talking about all the blockchains being Tendermint, so I think this can be very fast. All right, so like this is the example. Just as an example, like what you can do is have, what we're going to do is we're going to have a hub blockchain at the center. So it is a central system, right? Like in this case, the hub is acting as a center, and all the blockchains around the hub are connected to the hub. So these two sidechains are not talking to each other. So I mean, this is an obvious example where it's like Ethereum scaling, where each of these zones are running the Ethereum virtual machine. And if you had an account in one of the zones, you can move your tokens to another one by passing it first through the hub and then from the hub to another sidechain. So here's a way to scale out Ethereum. Another problem that this solves is upgradability. So, I mean, this is already, if you know Blockstream and the proposal, you probably already know about this, but this is a great way to upgrade blockchain logic. So, like instead of having to like hard fork when you come up with a new virtual machine, you can just plug a new one in and move your coins whenever you feel like. Right? And the Cosmos Hub, you know, it's not going to run on a virtual machine. We're just going to program it, and we're only going to be concerned about creating the right protocol between these blockchains. So it doesn't need to change much. What we're interested in is interoperability between many kinds of blockchains. So one example is having one of these be crypto node. So you can have your coin, you can move it into an Ethereum blockchain, run it through a smart contract, and take it out, put it into something that will anonymize your account, and then launder it, tumble it, whatever, right? So here's a nice way to plug in anonymity into a blockchain system. So in this case, okay, so this zone says Bitcoin, and what we mean by that is having like a peg. So by peg, what I mean is so let's say you have some Bitcoins on the Bitcoin blockchain. Imagine, so this is a terrible example of Bitcoin, because Bitcoin is difficult to peg onto because of the scripting system is kind of limited. But let's talk about Ethereum instead. So what we can do is we have a smart contract on Ethereum that represents, that's keeping track of the validator set of the Cosmos Hub, for example. And we can make it so that when you send any coin, any subcurrency, including Ether, onto this smart contract on the public blockchain, one of the zones will pick that up and it will issue pegged versions of those tokens onto the Cosmos system. So you can move your Ether onto a smart contract on Ethereum and have it materialize in our system, in the Cosmos system. And then now you can move them around and spend them. And imagine doing this to a lot of other chains. So picking up to and any other system. Now you can have a system. The Cosmos Hub is a multi-ANSI system. There can be all of these tokens on there. One can move tokens on that, trade them in there without any centralized exchange, having custody of those funds, which means the whole system is more secure. So I'm really excited to see that happen soon. That way we can get past all these exchange hacks. I can talk more about the exchange. We have the solution where it's a hybrid solution between a distributed exchange and a centralized one, where the system by system. And what we're creating is not like, we don't want the Cosmos Hub, like the first hub that we're going to create, to be the center of this universe. We want it to be a system where anyone can create their own hub. We want to make it a nice protocol for the future. So that's Cosmos. I'm going to talk a little bit about some of the details of it. So there's a staking. So it doesn't exist yet. We're creating this. It doesn't exist yet. But once we launch it, there's going to be a special token type called the atom. And the atom is a staking token. So it's not meant to be money like Bitcoin is. It's not a good store of value because it's a bit of an inflationary system. But what it does is it allows you to stake, bond them, pay them as collateral, so that you can become a validator on the Cosmos system, especially the Cosmos Hub. And that means you can earn transaction fees that are being paid by all the users of the Cosmos system. And you can also vote on governance proposals. So what we're creating is a system that includes its own governance mechanism in the blockchain. And we will have a constitution that defines the rules on like English terms, so people can agree have some social contract as to like what to do in various situations. And if people want to change any of these rules, they can pass a proposal and vote on it. So like when Ethereum split into Ethereum and Ethereum Classic, there was this huge question about like how to deal with the situation. And they polled the miners, and they also kind of polled the coin holders, but like only 6% of the Ether holders voted on it because like there was no social contract for anyone to be voting on any issues. So it was contentious, and I think that contributed to the fork, the Ethereum Classic being born. But what we can do in a proof-of-stake system is kind of make these stakeholders, these atom holders, be responsible for voting on proposals. Because they have to be online anyways. They're expected to be online and to be taking care of the system for the benefit of the users, so they might as well be responsible for changing what the rules are. So if you have atoms, you can stake, you can be part of blockchain consensus, you can secure it, and you can earn transaction fees, and you can vote on the system.
So I'm confused. You're saying that atom is not a store of value, it's not an medium of exchange, but it does have economic value. So what's the difference? I mean, where are you drawing the line? Are you expecting atoms to be something that will be picked up and traded on exchanges?
Yes.
Are they going to have a market value?
Yeah.
And what do you think that'll be, and how is that different from other cryptocurrencies? It sounds to me like you're trying to set expectations low by saying it's not a medium of exchange and store of value. Why are you doing that?
It's because, well, for the sake of our own, I think this is the right model, and I just want people to understand it before they get involved in it. For example, like Bitcoin kind of has this duality too, where there's the Bitcoin currency, but there's also the miner itself. Of course, it's not a token, and so if you want to trade it, you have to like physically ship these things. But imagine if the Bitcoin miners were virtualized and you could just pass them around. Okay? Then it would kind of reflect what we're trying to create. So the atom is like a virtualized miner. And if you don't, the way to use it and to earn anything back, the way to use it is to put it at stake so that you're at the risk of losing it if your server gets compromised. Yeah.
So you kind of view it as like a virtual capital good. It's what you call a higher order good in economics. It can be used to produce other currencies. So kind of.
Yeah. I wouldn't call this. It's not meant to be a security. Just to be clear about. Like, okay, so I'm not a lawyer, but it's not something where I'm not trying to sell anything where I say if you buy this, you're going to make money. No, if you don't know what you're doing, you're just going to lose your ads. It's not worth it. But I think it's similar in some respects to like shares in a company, because if you hold shares in a company and the bylaw says so, that you can vote on to replace the board. Anyway. So it's very different though, because that function isn't really used often, right, in corporations. So in some respects, it's also very different. Some other topics. So Tendermint-based blockchains, because all the validators are meant to sign and they all have to share signatures with each other. The more validators there are, the slower the system gets. So Bitcoin has like, I don't know how many miners have, like 50,000, probably like 100,000 or maybe more, if you count real devices. It would be difficult to have that kind of number of validators or signers on Tendermint today. But the nice thing is, as long as the internet bandwidth and the parallelism of computing power continues to grow exponentially, we can also support an exponentially growing number of validators. So, okay, what does this mean in practice? It means that today, on a global scale, we can have a validator set of 100 signers and meet that target of like 3-second block times very easily. And over time, that number of validators can grow depending on how fast the internet gets, and we can still support 3-second block times. If we wanted to increase this number to like 5,000 validators, then we can't have 3-second block times, but we could probably target like 30-second block times. So instead of letting anyone be a validator, what we do is we're going to create a delegation system. So it'll be a delegated proof-of-stake system where I can choose to delegate some of my atoms to other validators, distribute them according to whom I think would be good validators. But unlike other distributed proof-of-stake systems, in this case, like if the validator that I delegate to gets hacked, then I will lose my token. So it's really at stake. There's also some economics here where each validator can set their own commission rate. So fundamental economic stuff. We talked about governance. Yeah, so the Cosmos Hub, for example, is going to have all these parameters. Those parameters can be changed automatically based on the result of a proposal going through the system. We can also set a proposal that doesn't change parameter, but is meant to change the constitution. It's a fun little system. It's in the white paper, but I think it's worth discussing because it may not be the best thing. But we're proposing a system where a proposal is considered to be passed as long as the majority votes in favor of it, but a 1/3 minority can veto it. So it kind of is a pretty flexible system. We just talked about that. Yeah. So I'm not supposed to be talking about the fundraising in the United States because just to be safe, but you can read more about Cosmos by going to cosmos.network. And also check out our website, tendermint.com. Yeah, so that's Cosmos. Any questions? Really excited about it because it's going to be a nice proof of stake and a pretty flexible system as well. So we hope to solve a lot of the problems that exist in the cryptocurrency space, like scalability, for example. Still not solved in Bitcoin. Lightning networks work pretty well, but this is a different way of scaling it. We can actually have many blockchains to operate.
What have been some of your biggest challenges so far?
Technically, like one thing I'm working on now is so like the IBC stuff only works as long as we have good Merkle proofs, meaning and to have compact proofs, it's nice to have a binary tree structure. So Ethereum has a Patricia tree, which can do similar things, but it's got other problems there. You have to kind of hash everything before you put it in the tree, because otherwise people can kind of twiddle the keypad and try to proof move along. So instead we have this thing called an NAVL tree. We've created our own Merkleized self-balancing tree structure, but that means we have to create our own everything. We have to write the garbage collection of these things because we're talking about the mutable tree structure. So that's what I'm working on now. Things like that.
I How many developers do you guys have currently working on this?
Good question. So we're Tendermint is an American C Corp. Cosmos is going to be administrated by a Switzerland Foundation. But Tendermint,
I'm sorry, Cosmos is going to be administered by
a Switzerland Foundation. Yeah, so we're talking about two different entities. But Tendermint has 3 engineers right now. So me and Ethan are working on mostly core stuff, and Pong is fantastic with some of the UX of the website and building the wallet apps and everything. But we've also hired somebody who's going to be transitioning to joining us, and we're talking to someone else. So, 5-ish and growing.
I have a question.
Yeah.
And excuse me if I sound naive, but I'm a very good friend of Sarah's, and I don't really understand a lot of what you're saying. And is this an advanced presentation, or where does one go to learn about this from the beginning so that you can become? Are you trying to attract people to this format, or are you trying to talk to people who already know about this format?
I see. I guess a little bit of both. So
reading the white paper of any type of technology. White paper is the breakdown of what the tech does, what the mission is, the type of community that they're looking to build. The white paper is a great way to get started on any type of technology. Like with Bitcoin, the white paper came out, and it was like structured for what was going to be continually run up until this day, right? So you can do that as well at Cosmos Network and Tendermint to look at the white paper of Jae's technology, and then that kind of breaks down the whole mission. It also shows like Leo would be very interested in how the math works, right? You might be interested more in how it would work within your life, right? Which might be on like a front-facing, how you would move money or information quicker, right?
I would recommend probably learning about Bitcoin first, just because there's so much more literature about it. And then once you understand Bitcoin, then you can understand Tendermint and how it builds on top of that concept and how it's different. There's
a lot of the terms that you've heard tonight are broken down within Satoshi's white paper, but it's also the compare and contrast of what a proof of work system is versus a proof of stake system, right? Because within Bitcoin, you learn proof of work. And since Bitcoin, now we're seeing a lot more companies and different structures and entities starting to use proof of work, right? So it's kind of like a compare of that, compare and contrast of that.
I'd say, but overall, like this is definitely, it's been a talk catered for like developers and people who are very familiar with cryptocurrency.
Very familiar
with Bitcoin, for example. Yeah. Like one of our missions is definitely to make cryptocurrencies more accessible to people, but we're just not there yet. Yeah.
The whole space has another couple of years of hashing it out within developers and translators, right? People that understand how the tech is applicable to the everyday user, right? And being able to translate complicated code into advertising, branding, and front end, like what you would see on the front end of a website, or how you would navigate it, right? Okay, all of those things are kind of like a little bit delayed within the tech currently, because we're still trying to figure out the inside structure of a lot of these things, right?
Yeah, and you can find some YouTube videos that might be good to explain it. Talk to Sarah. She can make it.
Thank you.
But the end result will be that anyone can create their own. It's as if like you can you know how like Visa is like always up, like Visa is always reliable. Imagine if any developer could just copy that and create their own payment and their own stock exchange. All of that technology is open and free for everyone to run.
Mhm.
We're going to have so many different kinds of coins and tokens.
Well, when you talk about hackers, I mean, from what I know of hackers are like the bad guys who get in and corrupt and take over and steal from.
Yeah.
Is that is that generic? Is that what you?
There's different types of hackers.
I mean the good kind of hackers. So there's another definition.
There's a good guy hackers.
Yeah.
Yeah, it goes back many decades. Hackers, you know, ultimately just mean somebody who's working on a project and hacking away.
And working at it.
And yeah, and then it got, you know, the people were on the news and wanted to talk about the bad
It's not
guys.
like Mr.
It was
Robot.
the people that playing governments and dragons who were doing all the damage. So,
Okay, all right.
But there's white hat hackers and red hat hackers, right?
Black hat.
Black hat,
Oh, I didn't know that.
it's kind of like the heaven and the hell, you know?
Jay's definitely a hacker from heaven.
Hacker.
it's a good book
Hack is an onomatopoeia for the sound you make.
I'm sorry.
Hack is an onomatopoeia for the sound you make. It's like hack.
Oh, okay, all right. All right.
Yeah.
You mentioned how there are two organizations here with different governance, and can you go into that a little bit?
Sure, yeah. So like, the regulation around creating these things and even offering tokens is not very clear in the United States. Yeah, there's so much regulation and so much gray area, and even if you were to try to talk to a law firm, a big name one, like most of them have no idea how to approach these things. A few, I think, have people who like really understand securities law to be able to say sort of, yeah, if you do this, that's not security. But for most people, if you look at it, if you're selling a token, then it's going to look like a securities transaction, even if it's arguably not. So, so like due to legal reasons, especially even tax considerations, not knowing what the tax implications would be, like we just decide to go with people who have already figured it out. And there's lawyers in Switzerland who've already figured this out, and it's definitely a friendly jurisdiction. So that's what we're doing. I wish I could do this in the United States and know for sure that this is fine. It's just not going to happen for a while.
If ever.
Yeah, if ever. But you know, with Tendermint, it can be used in all kinds of blockchains, not just the Cosmos system. So you know, we definitely want to create a software company for that. It can be based on anywhere, and we like that one. Yeah.
And then the Apache 2 is for Tendermint?
Yeah, actually, we'll probably publish as much as we can for the Apache 2. So there's some, like Go Ethereum, for example, is a GPL, I think. So we have to re-release that GPL. But I think it's Apache, which is the best license for users. Yeah, that took a while to do. I want to go into the details of
That's a good decision.
yeah.
Any other questions? Greg, you gotta have another question.
Not really. I have a semi-question. How does the original allocation of atoms work? I don't know. You may have mentioned that.
No, we didn't. What we're going to do is have a donation fundraiser drive in February, and it'll be on the Bitcoin blockchain. And if you send Bitcoins to some address, we're going to tally all those counts up, they're going to get atoms proportion to how much they send it once that address.
And is it one atom, one vote?
Yeah, so we don't know how many atoms there will be because it depends on how much. Yeah, one atom. The amount of consensus and governance is proportional. Yeah. Anybody follow theory now? Yeah. So yeah, let's see. Have you guys read the Move paper or Polkadot?
The Move paper?
Yeah.
I sent you the link today in the email.
Oh, it was one of the
While I
links.
was talking about it.
Yeah.
Oh, it's an add-on to the Ethereum white paper.
Yeah, the mob. So, is it mob?
Mob.
Or
I've heard Move.
Move.
Yeah.
isn't that supposed to, is there color?
The color is not one
Is
I
that?
heard.
Yeah, I think they're calling it Move. That's in like just the white paper, the yellow paper, and Move. It's
Yeah.
color.
Yeah.
And now there was just recently the Polkadot paper, GAF released. So that's not a color.
I gotta catch up on my papers.
I don't know. There's too many.
I get them emailed in.
Hey, thanks for coming.
All right, yeah, thanks everybody for coming. Thanks for presenting.